Okay, so in this section we're going to talk about a critical analysis, and this actually is a culmination of both our single variable and two variable stats units, and it focuses on how we can look at studies and look at statistics and look at conclusions that people derive from statistics and have a critical approach to them. So in other words, how do we effectively look at statistics and people's summarizations or what they get from them, and see if maybe they have some actual point and reason to say what they say, or that if they're improperly implemented or used incorrectly, that we can critically look at the situation and sort of dissect it and break it apart. When I was doing my master's, we used to do this thing called paper group, where we would take a paper that someone had published, and one person would present it, and we'd spend the rest of the time dissecting what they've done and pointing out the flaws in their experimentation, their approach, and their suppositions and their conclusions and things like that. And it was an opportunity for us to, again, look critically at scientific studies and use it as an opportunity for us to decide whether or not how we could model our master's thesis, so that we would be eliminating all these possibilities of error and improper suppositions, and then doing, of course, a better job in that whole process. So anyway, this critical analysis is something that you can start to do, and you should be going back and looking at all of the different things that we've talked about through the last 2 units, qualitatively, not the number crunching, but the actual analysis of sampling techniques and measurement techniques and sources of bias and sources of suppositions or incorrect suppositions for causality, and the structure of scientific studies, or any studies for that matter, so that we can better understand if the statistics are valid or not. Okay? So it's a critical analysis of data that must be undertaken before we are to trust what we read or trust what people tell us. Okay? Just because they're in a lab coat and they did a scientific study and they crunched all the numbers doesn't mean it's true. We know the causality. Causation doesn't equal correlation all the time. We have to look carefully at the situation and how the experiment was structured in order for us to better understand it. This is a quote. There are lies, damn lies, and statistics. Okay, and it's originally thought by, it was said by Mark Twain, but it was actually by Disraeli. And the whole point is that you can lie, you can tell lots of lies, and then you can tell statistics, and statistics very often can be lies, and they can fool, and they can mislead. Okay, so be careful how they're used, how they're implemented, and how they're trusted. Okay, so when you're going to analyze any single variable or two variable stats, you need to make sure that you take these approaches. And really, I'm not going to go over this. This isn't going to be a long video, because what you're going to be doing is spending most of your time reading through the textbook and then going through the examples, because it's by example that you're going to find out where flaws can exist in a scientific study. And you have to be critical, almost even overcritical. You have to be, not trusting at all, and you have to try your best to make sure that those statistics prove to you that they're warranted, that the study proves to you that it's warranted by virtue of its structure. So what do you look at? Well, first, obviously, you look at the source of the data, the sampling technique that was used. How was the data gathered? Who was it gathered by, and how was it gathered? How was it measured in the gathering process? Was it appropriate? Was there any bias in all these different processes? And so there's some examples in your textbook that will illustrate why this is a big issue. But remember that all samples need to be random, representative, and unbiased. And if any of those characteristics are in there, or are not in there, okay, or if there's bias introduced, or if it's non-random, or it's not representative, then that's a flaw in that scientific study. And then, of course, the data needs to either be pushed back to say we need more data, or it needs to be refuted. Okay, sample size is another feature that's appropriate. Okay, and I know this seems to be the fact that we're focusing on sampling, but again, it's who we're measuring and how we decide who to measure and in what way that really makes a difference, because it's the generation of those numbers, not the numbers themselves, that lie. Okay, so the sample size is key. The closer you can get to a large sample size, the more appropriate it is. Okay, so keep that idea in mind. Finally, there's a couple of characteristics to consider, but when we're looking at two variable analysis, we have to worry about presumed accidental and common cause relationships. We have to look for causality, do a thorough causal analysis in order to understand, hey, is this really X really causing a change in Y, or are there a lot of other features that could play a role? If I told you that studying equals good marks, you're going to say to me, sir, there's all kinds of other features that are involved with that. That's not really true. It may help, but it's not really true. Okay, so there's all kinds of features that play a role in that, and you have to look at that critically and gather information about the principles that are at hand. Okay. And finally, you want to look for hidden or lurking variables, those key features that can cause common cause relationships or presumed relationships, but that those variables that aren't controlled, that can really cause the changes to exist, or that can be affecting how X causes a change in Y to maybe look like it's a stronger or, in fact, even a weaker correlation. So these are all characteristics that we need to look at. Okay. And that there's power that comes from sample size and correct sampling techniques. Okay? And that when you look for those causal natures, when you look for causality, or even a connection between individual variables and how they're gathered, or a connection between two variables, you need to be critical when you look at that. So look at these examples in your textbook, example 1, 2, and 3. Read them over, okay? And look at these features, whether they have to do with sampling and the causality and hidden or lurking variables and lack of controls in an experiment. And come to some sort of supposition about what's appropriate and inappropriate situations or suppositions that people have made about statistics. Are they correct? Are they incorrect? Are they correctly used or incorrectly used? Okay? And there's some homework to help you cement that understanding.